So what does an atom actually look like? Because it doesn't look like this. If you Google pictures of an atom, you'll see a lot of pictures like that. And even here at NOVA, we get it wrong too. All of these pictures are wrong. But if you could make the atom 1 trillion times bigger than it is, then the nucleus would look a little more like this, and the atom itself would look a little more like this. What does it mean to actually see something? I mean, am I seeing this cantaloupe? Because the cantaloupe isn't touching my eye. What does touch my eye are photons, particles of light. A photon leaves a lamp, it bounces off the cantaloupe into my eye. And then another photon hits at a different angle and then also enters my eye. That same thing happens with billions of photons. And if I retrace all those photons, then I can see the cantaloupe. And it's weird to say, but that's what seeing is. It's sharing a bunch of photons with a cantaloupe. We can sort of see a hydrogen atom using a similar method. Take a few high-energy photons and shoot them at a hydrogen atom. The photons don't bounce off like with the cantaloupe, but what they do is they knock one of the electrons from the hydrogen atom out, and it flies not to an eye, but to a detector, say, here. If you do it again with a second hydrogen atom, the electron would land, say, here. If you do it again and again and again, what you'll eventually get is this cloud. Tracing those electrons back to where they came from, you'd find all the places you're likely to find the electron within the hydrogen atom if you were to look for it. This cloud of probabilities is beautifully different for different atoms. Okay, so the standard picture of the atom should maybe look a little more like this. But what about the nucleus? Because in this picture, relatively, it's too big. If the electron cloud were the size of a football field, then the nucleus would be the size of a grain of sand. 99.99999% of an atom is actually empty space. Physicists don't think of the nucleus as a cluster of protons and neutrons like a cluster of grapes. They actually learn about it in a similar way as the electron. They actually shoot electrons into the nucleus and protons and neutrons come out the other side. And what they learn is that the nucleus is much more like a droplet, a region where you could find the proton or neutron. It's sort of like the electron cloud, except much more dense. And they don't yet fully understand what's going on inside the nucleus, but they do know that the nucleus comes in cool different shapes for different nuclei. While our standard picture of the atom is a pretty good schematic, to be a little more accurate, we might want to imagine the atom more like a cloud with a tiny droplet in the middle. For much more, check out Nova Wonders, What's the Universe Made Of? And if you want to see more What the Physics, please subscribe. I can't believe I caught it and then dropped it.